Hey everybody, in this video we're going to look at how to graph a square root function. Our main concern is just getting a good idea of which direction it's going and being able to label points to show approximately how steep it is. What we need to draw is we need to draw the endpoint. We'll need to have it going the correct direction, and knowing the domain would be helpful for this. And then we just need to get another point. And we can use our transformations. We can also just plug in a number that we think would be easy to work with. There's plenty of ways that we can make that happen. So here's the function. F of x equals square root of negative 5x plus 1. First thing I should notice is it's a square root function. So it's going to look like this shape in some form. And then I should see that it has a reflection over the y-axis, but no reflection over the x-axis. So while it's still going to point up, this specific one is also going to point to the left. One thing that might be helpful is for us to find the domain, which would also reinforce the fact that it's pointing to the left. Again, we know that inside the radical cannot be negative. It can only be 0 or positive. So we're just going to take the expression inside the radical, negative 5x plus 1. And we know that negative 5x plus 1 has to be greater than or equal to 0. So after I set up and I solve the inequality, I get x is less than or equal to 1/5. So the domain is from negative infinity to positive 1/5. And again, this should reinforce two things. Number one, that it's starting at x equals negative infinity, so it would be pointing to the left. And then number two, the endpoint is 1/5, which tells me where the function's going to start. Knowing that it's going to start at x equals 1/5, we can evaluate the function for this value to find the endpoint. After substituting x equals 1/5 and evaluating the function, I see that the function's value at x equals 1/5 is 0. Now, it shouldn't be surprising. Based on what we know about transformations, the fact that we set the expression under the radical equal to 0, all we were trying to do is just to make the output of that part to be 0. And then the y value stays at 0 because there's no other vertical transformations. There's no vertical stretch or compression. There's no reflection over the x-axis. There's no vertical translation. One of the other things I should notice is that I'm just transforming the parent function, which begins at the origin. First I move it 1 to the left, which would put it at negative 1, 0. Then I do the reflection over the y-axis, which would put it at positive 1, 0. And then I do the horizontal compression by 1/5, which puts it at 1/5, 0. Now, knowing that 1, 1 is on the parent function because the square root of 1 is 1, I could do the same kind of process to get my second point. Or I could do the algebra way of the transformation to show where the radical would just be 1, which would be nice because taking the square root of 1 would just give me 1 and give me something nice to work with. I could pick any number, although I really want to be careful since it's a square root. I should try to pick a smart x that would help me actually have a rational number and something that's easy to draw on the graph, especially since you can't use a calculator for this. So if you can think of a good x value in your head that would give you a perfect square, that's a very good way to go with this as well. So if I want to do the algebra way, I'll just take the expression under the radical again, negative 5x plus 1, and this time I'll set it equal to 1. By solving the equation, I see that x equals 0 is a good x value to use for this. Now if you're really skeptical, you could actually substitute the 0 for x and you'll actually see that it's 1. But you should also just see, because we actually set the expression underneath the radical equal to 1, it should actually be 1. And again, it's going to stay 1 because there's no vertical stretch, compression, reflection, translation, so nothing else is going to affect the y value. So finally, the only thing left to do is draw the graph. So I make sure that the end point of the graph is 1/5, 0. I have my second point at 0, 1. And again, I just make sure, I thought about what the graph should look like before I drew it. So I just need to verify that my graph is going the direction I want it to go. So, in review, that's all the things that you need to make a quick, good, accurate sketch of a square root function. Find the endpoint, which the domain might really help you to do. Figure out which way it's going. Find a second point, and then just draw it.